Hi, class. It's Dr. Lindner. Let's take a look at skeletal muscle fiber types. When we look at fiber types, you may hear the term slow twitch fibers or fast twitch fibers, right? You're going to hear slow twitch or fast twitch. You'll also hear white fibers and red fibers. Okay, so red fibers are slow twitch. And if you look here at slow twitch, they look darker, and fast twitch look white. All right, so I just want to point that out. So, to help us understand this, I want you to think about Thanksgiving time. When you think about Thanksgiving, if you think of a turkey where many people celebrate it with a turkey, the big debate around the table, if you're a carnivore and not a vegetarian, of course, people would debate and say, all right, who wants the dark meat or who wants the white meat? Right? That's the big debate. So some people prefer dark meat, some people want the white meat. The dark meat is found in the thighs, and the white meat is found in the chest and the breast region. So the breast meat is white, and the thighs and the legs are dark. Why is that? That's because I haven't really seen turkeys flying around Nassau County. Have you? I haven't. So if a bird was using its wings quite a bit to fly, then that means those muscles are contracting quite a bit. The breast muscles and the chest would be functioning quite a bit, which means it needs a lot of oxygen and it needs a lot of blood. If it needs a lot of oxygen and a lot of blood, then it's going to be darker. It's going to be dark red. So in flying birds, the breast is actually dark and the thighs and the legs are white. But in turkeys, since turkeys are not flying, the breast is white, doesn't need lots of blood and nutrition, but they're moving throughout using their legs and their feet and the thighs. So the thigh muscles end up being darker. There's more myoglobin in the legs than in the wings. So if we look at the red fibers, which are the dark meat, these are known as slow twitch fibers. They have increased myoglobin, more blood. They have increased mitochondria, more energy production because they're being used more. So they're used for endurance. They're used for postural muscles of the back and your calves. Whereas your white twitch fibers, these are your fast twitch fibers, they have little myoglobin, they have less mitochondria. So these white fibers are used more for power and speed. They're only used for a short duration. This is like a quick sprint, or this is like a quick power lift. They fatigue easily because you don't have lots of energy, you don't have lots of mitochondria. Whereas the red twitch fibers, these are like your Olympic runners, these are people that run marathons. These are better for endurance and postural muscles. So, like your calf muscles, you can stand for hours. Your back muscles, your posture can be maintained for hours. They're red fibers. Your white fibers, these are the muscles of your eyeball. They can move quickly, but they fatigue, right? If you're reading, people read and all of a sudden their eyes get tired and get heavy and you fall asleep because the muscles fatigue easily. So now you understand the difference between the white meat and the dark meat. The fast fibers, the fast twitch fibers, they contract fast, they contract very quickly. They have large glycogen reserves. They have very few mitochondria. So you can have a strong contraction, but they fatigue pretty quickly. So these fast twitch fibers, those are the muscles of the eyes. Your slow twitch fibers, they contract slowly. They're slow to fatigue. It's in parts of the body where you have lots of mitochondria. You have a great oxygen supply, lots of blood. So these are your red fibers. The red pigment's going to bind to oxygen. The more oxygen that enters the mitochondria, then the more ATP you can produce. Okay. So the white muscles, the white fibers, these are your fast twitch fibers. They look pale, they're white. Think of the chicken breast. The red muscle, that's your dark. You're thinking the chicken legs and the thighs. These are mostly slow fibers. And humans, we have both. We have mixed fibers. We have a combination of red and white. Some of them are even pink. They could do both. Okay. In terms of hypertrophy and atrophy, atrophy is when the muscle wastes away, right? If you're not using it, you lose it. If you're not exercising due to a lack of muscle activity, maybe the person is sick, they're bedridden, maybe they break a limb and the limb is in a cast and they can't use it. What happens is the muscle size is reduced. Reduced size, reduced tone, reduced power and strength. That's called muscle atrophy. Muscle hypertrophy is just the opposite. Muscle grows from heavy exercise and training. You can get an increase in the diameter of the fibers and the number of fibers. And when you exercise, the body goes through something called mitochondrial biogenesis. You go through mitochondrial biogenesis, which means you increase the number of mitochondria. If you increase the number of mitochondria, then you increase the fuel centers that you have. The more mitochondria, well, the more fat you can burn, the more glucose you can burn, and the more ATP you can produce. So you can actually change your body composition, not just by doing aerobics, like going on a treadmill, being on a bike. A lot of people think that's the only way you can change your body composition, but you can weight train and resistance train and put on muscle. And the more lean muscle you have, the more mitochondria you have, the more mitochondria, the more fat cells you can burn off. So here, these are the postural muscles of the calf, right here. Those are slow twitch fibers. They don't fatigue very easily. But the fast twitch fibers, these are the eye muscles. These fatigue pretty easily. Okay, we spoke about hypertrophy and hyperplasia. Between the age of 30 and 50, maybe 10% of the muscle tissue is replaced by fibrous connective tissue and fat. And then between the age of 50 and 80, another 40% of muscle tissue is replaced. And the consequence of that is muscle strength and flexibility tends to decrease with age, and reflexes become a little bit slower. This is why resistance training and weight training is so important. I've been at the gym since I was 14 years of age, have never stopped. I take my children to the gym with me. I take my 14-year-old boy. I take my 12-year-old girl, my little guy, 9, a little bit too young. But it's very important that maintaining muscle mass and increasing muscle mass when you're young is super, super important. And then maintaining that as you get older is just as important, if not more important. Okay. Muscle is super important to help with strength, to help your neural system. The more you move your muscles, the more you move your body, the healthier your brain is. The healthier your brain is, the healthier your body is. A slow moving body is a slow moving brain. You always want to move your body so your brain is stimulated. Okay. One of the things I do with my patients when I examine them, I look at their hands, and now you know that these are where your metacarpals are, and between them in these spaces, there's muscle. So when you see this type of appearance where you see hills and valleys, like you see here, hills and valley, hill, valley, hill, valley, when you see these depressions, there's muscle wasting that's going on in between here. That muscle wasting is called sarcopenia. And it's either the person's not consuming enough protein in their diet, or they don't have enough digestive enzymes to break down the protein that they're eating. Okay, but it's not something we want to see. If this is happening in the hands, then it's happening in their legs. And what happens if you have an elderly person that doesn't have strong legs, that have weak legs? Then what happens to their balance? They lose their balance, they fall, and they can break something. Okay, that's a possibility. So, what I end up doing with my patients, even when they're younger, I start challenging them on this now. We use a dynamometer. Dyno, Dynamometer. When you squeeze this with your hand, there's this needle that's right here that moves up, and then there's a marker right here. There's a thinner needle. So when you let go, the thinner needle remains, and you can see, okay, they have 80 pounds of crushing force. And then you move it to their other hand and they squeeze it as hard as they can to make sure that it's 80 pounds of crushing force. You obviously want to see pretty close to equal between left and right hand. There's lots of studies out there that show that the strength and grip strength and mortality go hand in hand. The stronger your grip is, the longer you're going to live. So you'll see a lot of trends right now on TikTok and Instagram, these trends where people go to see how long they can hang on a bar. They want to increase their hand strength. Um, I think I have a video on, I don't know if it's my Facebook page, maybe my TikTok page, one of them, where I actually talk about this and I demonstrate this to show that you can increase your hand strength. I think when I first started testing myself, maybe 20 years ago, it was probably somewhere around like 120, 130. And then recently I tested myself and I was able to get my hand strength up all the way to 180. Okay. I think it only goes up to 200. So hand strength is very, very important for elderly and for the young. Now, if a person has weaker in one side and not the other, maybe it has nothing to do with protein and muscle strength or muscle mass. It can have a lot to do with nerve supply. So there are many patients that have neck problems or wrist problems, like the nerve in the wrist is being compressed or a nerve in their neck is being compressed. And if the brachial plexus in the neck is being compressed, these muscles could be weaker. So we also use hand strength as a biomarker. If someone has a pinched nerve in their neck, we'll make an adjustment to their neck and then recheck the hand strength to make sure it goes up, to make sure we're moving on the right pathway. Okay. Okay.